Angle properties of a circle. We have seen various parts of a circle, that is, chords, arcs, sectors, and segments. Angles in the same segment. Consider the figure below. AB is a chord. It divides the circle into two segments, that is APB, which is the minor segment, and AQB, which is the major segment. AB subtends angle X and Y on the circumference of the circle. Angles X and Y are always equal. In general, a chord of a circle subtends equal angles on the circumference of the circle on the same segment. Equal chords or arcs. Consider the figure below. AB is equal to CD. Angle M is equal to angle N. In general, equal chords or arcs subtend equal angles on the circumference of the circle. For example, find angle S and R in the figure below. In our solution, join Q to R to make chord QR. The chord QR subtends angle P as well as angle S. Hence, angle S is 30 degrees. Angle SXR is 80 degrees from the direct opposite to angle PXQ. Thus, angle R is equal to 180 minus 80 plus 30, which are the angles of a triangle, and R is 70 degrees. Angles in a semicircle. PQ from the figure is a diameter of the circle. It subtends angles M, N, and R on the circumference. All these angles are 90 degrees. Generally, all angles subtended by the diameter are right-angled. Angles at the center and the circumference. Consider the figure below. PQ is a chord. PQ subtends angle O at the center and angle R on the circumference. Angle R is equal to a half angle O. That is, if O is 80 degrees, R is 40 degrees. Generally, the angle subtended on the circumference of a circle by a chord is half the angle subtended at the center of the circle by the same chord. For example, AB is a diameter. O is the center of the circle. Angle B is equal to 25 degrees. Find angles A, B, C, and X. In our solution, taking AC to be a chord, it subtends angle X at the center and angle B on the circumference. Therefore, if B is 25, then X is 50 degrees. Meaning, angle Z is equal to 180 minus 50, which is equal to 130. That is angles on a straight line. It follows that angle Y is equal to 180 minus 130 plus 25, angles of a triangle, which is 25 degrees. If AB is a diameter, then angle BCA is 90 degrees. Hence, if Y is 25 degrees, then angle C is 90 minus 25, which is 65. Angle A can be obtained in two ways. One, if angle C is 65 and angle X is 50, then angle A is 180 minus 65 plus 50, which is 65. That is total angles of a triangle. Taking BC to be a chord, it subtends angle Z at the center and angle A on the circumference. If angle Z is 130 degrees, then angle A is a half of 130, which is 65 degrees. Cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral whose vertices lie on the circumference of a circle. Angle X and Y are supplementary. They sum up to 180. Equally, angle M and angle N are supplementary. Generally, opposite angles of a cyclic quadrilateral are supplementary. Exterior and interior angles. Angle Q and angle P are interior angles. Angle R and angle S are exterior angles. Exterior angle S is opposite to interior angle Q. Equally, exterior angle R is opposite to interior angle P. Angle S is equal to angle Q and angle R is equal to angle P. Generally, an exterior angle is equal to the opposite interior angle. Example: find the missing angles. Angle Z is 50 degrees. That is, interior angle is equal to opposite exterior. Angle Y is 180 minus 80, which is 100. That is opposite angles of a quadrilateral. Angle M is 80 degrees. Exterior angles is equal to interior opposite angle. And finally, angle X is 180 minus 80 plus 50, it is 50, from the fact that it is the sum total of angles of a triangle.
If you want to go on and major in math or do honors in math or do a career in math, you really do need to be good at it. But I think too many people stop out too soon because they've had bad experiences. I think math teachers have a lot of responsibility for that. We haven't taught it so well. We haven't provided the resources that people need. And so I think if you need help, you need to get it, and you need to get it early. And you need to work at it.